Everybody, it's John and Kyle here from the Baseline Protocol, and we're going to be talking now about, we're going to be doing a session we call Code Don't Lie. And Code Don't Lie is where we walk through the new code of the init core branch that would be pushed in the next month or so.
So there's 6 packages that we need to look through, or we need to talk about. Some of them are, there's really only 3 that I think you really absolutely must implement, really 4 that you absolutely must depend on. So there's really 4 packages I think you need to absolutely depend on if you want to build something that can be considered baseline compliant, or in the future, or I guess be positioned to absorb the rapidly evolving updates to the protocol, or maybe not rapidly evolving, just evolving updates to the protocol. Those packages are the API package, the contract package, the messaging package, and the privacy package. The persistence and the types packages are not necessarily required in order to implement the core, like, or a minimalistic baseline implementation. Or application, or just process circuit. So we'll talk about this, the persistence and the types packages as well. So the first package is on the list is the API package, and what that is a standard or a unified interface of the JSON RPC, the baseline JSON RPC module.
So for context, Rad 34 was a demo that kind of gave us all a lot of ideas about how to build a protocol. Yeah. This is the first release of what you could call early 0.1.
This is the packaging that forms the protocol and packaging, right? And then like we will use the architecture here to inform the standards. So if we want to dig through on the level of, I got it in IDE, we can also look at it on the level of GitHub and maybe a little bit more content to sort of look at. So if we look at the API, what we see are a couple things. We have the baseline JSON RPC module, which is essentially a design that ties it's basically an interface to the off-chain Merkle tree database, and it's a way to deploy shield contracts very easily, or track existing shield contracts that have already been deployed. And so we're now using this to deploy shield contract. It's actually the same shield contract, or it's basically the base contract that was the shield that was being inherited in the Rad 34 shield, which is the Merkle tree SHA contract that the EY blockchain Timber project.
I'll translate a little bit. What you're saying is that there's the shield contract, first of all, for people that don't know, is the container for the Merkle tree that stores the baseline proofs. And if you don't know what that is all about, then just go through the docs, right? The docs will tell you why you want one of those, and what the fact that a baseline proof can be used as a state marker, a key and key value lookup, and a way of confirming that every counterparty to a particular work step in the baseline workflow has generated the same results from the same code with the same inputs, and basically has the same record in their respective system. The shield contract is a part of the zero knowledge
verification
process that verifier circuit.
Right.
You can go through that, and then you have a shield contract so when you try to push the baseline proof into the Merkle tree inside the shield contract makes a phone call over to the verifier contract. Verifier contract has to return true. We can go into why and how we do that.
Yeah.
And all of that is to say that you wind up in a shield contract being able to hide a lot of attributes, right? So you can say somebody did something with something, which allows us to not allow people just to be observing these Merkle tree morphology changes, right? And say and ascertain some information about who's doing what. Is that
that's a fair statement. Like, it's really more of it is about, like, that's sort of like an abstracted. But when I say it's a state machine, it's the state machine. Sort of what I mean is that, like, you cannot progress the state of the process, if the shield contracts doesn't allow it.
Right. So that's okay. So you're focused on a different thing than I was.
It's the same thing. It's just said differently.
So there's a set of functions that a shield contract contains that allow you to do things like check ordering and other, right? So you can say this Merkle tree item can't happen before this other Merkle tree, or which one happened before the other, and so you can call those functions from. Those are all contained in the shield contract, right?
So I'm the shield contract that we're using. Okay. So what we're doing is we're basically using the EY blockchain Timber shield contract, the Merkle tree SHA contract.
Oh, this is beautiful. This is what I want to see, man.
This is exactly. So this is the contract that we're using. So when you call baseline deploy, it says deploy a shield contract. So it's actually so if you call baseline deploy, it deploys. There's actually another. There's a hidden method. It's not like baseline deploys an arbitrary contract. There's another method that we have. It's called baseline. It's actually not documented because I don't think it should be a part of the standard because it's a little bit too. It's just basically a little hacky. What it does is it. Actually, no, it's baseline deploy. What it does is it lets you name the contract, and that contract must exist on the RPC endpoint, but the artifacts already have to exist. And so the way that that we're doing it in the spec here in the API spec, right? Like, we have a deploy shield method. Like, if we actually wanted to run these tests, we would. We run an npm test within, for example, the API directory. It's going to run this suite. It's actually run the baseline RPC suite. It's going to run the provide spec suite. And what these suites do are they test like all these methods are wired up properly, and so like they have it.
And that's different from in the original stuff we had something called the registrar contract, right?
The registrar contract.
Registrar is a factory contract that generated a shield contract, a verifier contract, and an org.
Oh, yeah, sorry. Yeah. So this is basically, there's no registrar contract anymore. Yeah, there's just like there's just the ERC 1820 contract, and it's like
that's kind of important to know.
Yeah, well,
and actually, Kyle, what you just said, and we can keep this on the record. That significantly changes something that we're doing with the gas service over here.
Well, it depends on what
we were instrumenting the registrar factory contract to make all the 3 resulting smart contracts metatransact capable.
Yeah, so what we're. You can still follow that pattern, like, if you wanted to, but like it really needs to be more of like. It's sort of decoupled from the actual org registry, right? Like, the org registry happens, like, you come into the org registry and you have your messaging endpoint sort of registered on chain, and then you that's done, right? Like, you tuck that away, and then the next step in the process is, well, let's define more and more circuits that we're actually going to use for the business process. Each one of those is likely going to need its own. It's going to need its own shield and its own verifier contract. And so what you do is you using the privacy package, which we'll get to, you actually can deploy those sort of all in one. You can, like, do the trusted setup and get the verifier back all in one step.
So it almost looks like this, that we've broken it up into more a la carte. Like, as a developer, you could.
Yeah, that's why I say you only need 3. Yeah.
Right. You deploy a shield contract without the org registry or the verifier if you wanted to for some reason.
Well, you need to, right? You need to be able to deploy the shield and the shield verifier outside of the registry because the registry is already like you have to assume that the registry is going to have lots of processes managed by it. And so like one verifier, one shield pair, and hopefully in the future just one shield contract in general and a whole bunch of verifiers. Really,
Are you saying that is the cardinality here? This is really interesting.
Isn't it cool?
Now, what a work group is defined by an org registry and a workflow. You can have multiple workflows defined by a shield contract and a verifier.
Yeah. So basically, you have a work registry. You have a bunch of participants. You might have one or more circuits within that, and each one you need to deploy the circuit.
Stop. Hold right there. Circuits. You're talking about circuits. Circuits aren't on chain.
They're not. But the fact that one exists is the thing that actually matters when you're thinking about what does go on chain.
Right, but the cardinality of a circuit should go down to the workflow step, right? I have a circuit for workflow step.
Yeah, exactly, right. But each workflow step,
right?
Yeah. Each workflow step itself, though, can have its own shield logic and it will have its own verifier, right? So that's the whole point. So each workflow step within it, like if you define a workflow within a work group, you would have potentially n number of circuits. That means with each one of those circuits, you'll have, as of right now, today in this current implementation, you'll have n number of shields and n number of verifiers that are deployed to the blockchain. So that's why it's decoupled from the registrar contract. From the example, you have to do this like for every circuit you want to deploy, or let's not call it a circuit, or maybe just call it a workflow step. Sort of use that as a synonym. Every single workflow step that you add, you really, as of today, are deploying a new shield verifier pair, and all that has been made a lot simpler in this core branch. Now, what will be interesting is how we can iterate a little further on this with maybe making the shield contract a single shield contract for the work group, and then having multiple verifiers. And this is where the upgradability and potentially the diamond pattern that was mentioned on today's call can come in. You can have shield contract, basically they'll be able to delegate call into the appropriate verifier contract depending on what the call they look like. So that's sort of the next step.
So you got a lot more flexibility, and people, but then people are going to need to learn how to manage that flexibility, right?
Yes, but that actually happens in the privacy package. There's rails around it in the privacy package to make it easier to.
Oh, very good.
Yeah, so we'll get there. That's why I say you need if you want to become a baseline client, you really need these three core packages that you really need to use, and then that assumes the fourth package, the contracts package, is actually also being used, but maybe it's just already been deployed for you, right, on the mainnet or in your work group or wherever it is.
Okay, all right, so that's good. So that's a big change, right? No more registrar contract. What does it mean for you that you're deploying a registry in 1820, and I think what you're just calling that into org registry is then.
Yeah, it's repeatable, right? So now what I can do is I can go into, it's a repeatable thing, right? I can now run, for example.
Basically, in order to create a work group, all I need to do is create a work group.
All you got to do is create a work group. So basically, like.
And what is that work group doing for me?
The work group is the on-chain registry for all the organizations. It's the phone book.
It's the phone book, but I mean, what is that doing for me? Why couldn't I just call people? Why couldn't I just know in the code? I called it a Rolodex.
Yeah, it's a Rolodex. It's the on-chain Rolodex.
But beyond being a fast lookup, it never seemed to me that it did much.
Well, it's where all the keys live, right? It's where the public keys live. It's where you can establish other methods of encryption, such as like Diffie-Hellman. Having those public keys in a single place is really important. So for example,
does that create an opportunity for somebody who wants to do an exploit to grab a bunch of identities that might be obfuscated, but still, right, and do set analysis to figure out who they are and what?
I don't think so. Insofar as just having, I don't think so. No, I don't believe there's. I don't believe there's any like current like vectors that are exposed simply by having an organization's name and some random, random public Ethereum address associated with it.
Have you seen what we can do with class?
Yeah, you're assuming additional things like the fact that maybe we would be using that public key to sign transactions. Like the pattern is never to use that key at all. Always use it as a public key, like an index on the organization.
Right, does it show up anywhere else but in here? That's the thing, right?
It doesn't though. It just shows up like the index.
So then it's noise, right? So it'd be noise.
It's not noise. It's not noise. It's a way to look up the organization. Like you have the organization's public key. You can say, hey, give me the organization's messaging address because I need to
so couldn't I go and look at a bunch of in the real world, right? If I couldn't I go and look at a bunch of different org registries, say, oh, all these guys are baseline. Imagine a world where everybody's baseline.
Yeah, absolutely.
And then you go, well, this group, this guy is showing up. This public key shows up in these 15 different groups. I know that I'm in these 12.
Oh, I see. Yeah,
I know that this one group only has 2 guys in it. And I know that guy is this guy.
Yeah,
I know he's in these other 12 different groups.
I see. So there's 2 things going on. One is the thought of having a global registry of all these parties, and then having another individual work group registries that are also on chain that are referencing the original keys, right?
Yeah,
so,
I'm late for a second.
Yeah, the answer to that is no. That the way that I conceptualize this is that you never see the key ever again. But yeah, we can dig into that.
Yeah, let's come back for round 2. I'll be right back.
Enjoy. See ya.
This is awesome.
Yeah, it's gonna be really cool. See you, man.